Right, in this video we're going to look at an example for each of these different situations. We're going to see one where the lines intersect with one solution. In that situation we know that the variables that are important are the coefficients of x and y, as we see in the equations, and the ratio between them. Also we can see sometimes the lines are parallel, so parallel like this, or they could be coincident, the same line, in which case the first part is the same. The key difference is that the constant terms, which is the vertical shift, is not equal if they're parallel. So let's keep that in mind and see how we go with these three questions. We've got, in question 2, the solution of this system of equations we're given. So we could say that there's one solution. The solution, there's one. So in that case, we know that the coefficient, the ratio of the coefficients of x, can't be equal to the coefficient of y. But in this case, if we simplify this, it doesn't get us very far. We just know what k isn't, but we're asked to find the values of, we want to find the values of k and t. So what we're going to do instead is we're going to use the values that are given to us here in the question. So we've got here that x is -1, y is 3. And so now we can substitute these values into both of these equations. So let's do this one in green. We've got k times x. Well, x is -1, so that will make minus k, plus 2 times 3 will give us 6, equal to 5. And so now if we simplify that, subtracting 6 would give us -1, so k must be equal to 1. And let's do this second part in in red. So we've got 2 times the x value is -2, so -1, so the answer will be -2. -3 times by 3 is going to give us 9, equal to t, and I think we can agree that that will be -11. And we check and that's correct. Alright, so in question 3, the following system equation now has no solution. So remember, if there's no solution, that means that they're parallel. So that means that the coefficients here of x, a plus 1, over 2a minus 3, must be equal to the ratio of the coefficients of y. Notice that these equations are already in general form, so we could just read them straight from the equations. So now we can see that we've got 7a plus 7, just using a bit of cross multiplication, multiplying by 7, multiply the right hand side by 4, and we've got 8a minus 12. Group together our like terms, so subtract 7a and we'll just get a. We need to add 12, and we see that the value of a is 19. And as always, we can check our answer here, 19. Alright, so question 4, the last in this video, we've got the system of quantities have infinitely many solutions. So that means that the ratio of the lines are parallel, the slopes are the same, so the coefficients of x must be equal to the coefficients of y, but more than that, also the vertical shift is the same, so that is also equal to now we have to get these constant terms. This whole both of these terms are the constant term. B is just a real number. So we have this equation here. So let's do this, solve these one at a time, because we want to find the value of a and b before we can find a minus b. So let's do this part first. We have, using cross multiplication, 3a minus 6 equal to 28. We want to add 6 to both sides, so 3a equal to 34, and lastly divide by 3. Alright, so we'll leave it like that for now, and let's now look at the right two equations here. So this is to find our value of b, using cross multiplication again, minus 20. You might like to pause the video and go ahead and try this for yourself. Plus 6. So 3b, let's add add 20 to get 26. Lastly, divide by 3. 26 over 3. The last thing, don't forget, to read the full question, we want to find the value of a minus b. So a minus b is equal to 34 over 3 minus 26 over 3. So it's a good thing that we left the answers in this form, because the denominators are the same. It makes it easy to simplify. Easy to simplify. Just subtract the numerators and we have 8 over 3. and check our answer. You beauty.